Hello everyone, welcome to week 10 of problem solving session of computers communication networks. So we will be today solving the problems based on the lecture material for week 10 of computer communication networks. So today we will be this is week 10. This is week 10 of computer communication network, and this is CSMA CA, CSMA CD. These are the topics, and additionally we will be also talking about reservation, token passing, etc. So CSMA CA and CSMA CD are random access methods, whereas reservation token access are all examples of controlled access methods. So we will also learn about controlled access methods today. So this controlled access will be reservation and token passing. In the previous class, we have briefly talked about CSMA. So CSMA is carrier sends multiple access. So firstly, we had Aloha. So in Aloha, the problem was that the carrier, the sender, sends message at a particular time without any regards to the current channel conditions. So regardless of the current channel conditions, Aloha will send the message. So this was not very efficient because it was very collision prone. If every carrier just sends their message whenever they have to send their message without any consideration for others, then there is bound to be a lot of collisions because they are not considering when others have to send, and they are just relying on luck to get no collisions. So you are only relying on luck to get no collisions. So our next attempt will be more refined, and this is CSMA CA and CSMA CD. So CSMA is, in short, carrier sends multiple access. So so now carrier sends. Now we have carrier sends multiple access. So here the multiple access happens with regards to the carrier, that is the channel. So the channel is first sensed. The channel is first sensed and it is decided whether some packet is transmitted or not, and then accordingly the message is sent. So carrier sends multiple access, you will in carrier sends multiple access you will pay regards to the users that want to send the message or are currently sending the message, and you will wait patiently for your turn, rather than like in Aloha when people were sending their message whenever they want to send the message. Now CSMA comes in two flavors. One is CSMA CD, which detects collisions. So here only you will know when collision will happen. So it will sense the carrier and it can tell when transmitting will lead to collision. But it does not do anything if and when collision has happened. So it does not do anything to prevent the collision. It can only predict the collision. So this one predicts collisions. So if it can predict collisions, then you can wait till you get a clear path to go ahead. Whereas CSMA CA is more complicated to implement, but avoids collision. So you don't have to wait for when the prediction of collision will not be there. So you don't have to wait till that. You will avoid the collision. You will send your packet such that you will avoid the collision. So this is more sophisticated. So this is more expensive. CSMA CA is more expensive to implement than CSMA CD. Now, CSMA CD or carrier sense multiple access with collision detection is when the algorithm can detect the collision, but it cannot avoid the collision. So if it can detect the collision, then it can abort transmission based on that. That is the only method they can take. So CSMA CD in short is that you will, whenever you have to send your message, you will try to predict whether sending this message will result in collision or not. So if you think there has been a collision when you have sent the packet, then you have to retransmit the packet. So here the logic is if collision. So this is not avoiding collision, it is just detecting collision. If collision, then retransmit. So it is just detecting whether collision will happen, and if collision has happened, then it will just retransmit again. It will try again. But retransmitting the same message again and again is not a very good use of the bandwidth and the channel resources. So we cannot theoretically go on using the channel bandwidth and channel resources and send the same message again and again, because if the old message is still in queue, the newer messages will also get delayed. So the overall delay will increase. So at one point we have to abort sending the message, and that is the maximum number of reattempts. So that is usually kept at 15, which means you can at most 15 times try to send your message. But if you cannot get your message through without collision in 15 times, then you have to abort. So we will start with k equal to 0. Then we will apply one of the persistence methods. So we'll start with k equal to 0. K is the reattempt count. So k is the reattempt counter. So it counts how many reattempts you have done to transmit the same message. Reattempt counter. So obviously it will start with 0. Then you will apply one of the persistent methods. What is persistence method? Persistence method means waiting algorithm. Persistence method is nothing but waiting algorithm. So it is if every sender tries to send the packet exactly at the same time in CSMA CD, then of course you will detect a collision. So if everyone starts at the same time, then you are guaranteed to get collisions from the beginning itself. So if you are guaranteed to get collisions from the beginning itself, then that is not a good sign. So so basically you make all the senders that are accessing the channel, all the users send their messages at different instances of time. So they will wait for different random amounts of time and then they will send their message. So this waiting, so who will wait what amount of time, that is called a persistence method. Now there are three types of persistence method. There are three types of persistence method. So one is the uh, so one is the one persistent method. In one persistent method, you will continuously sense the channel. So you are continuously sensing the channel, and whenever and wherever you find that the channel is not busy, that is someone is not transmitting any message, you send your message. So in one persistent method, transmission begins immediately after channel is available. One persistence means so transmission begins after, just immediately after. Immediately is the key word here. Begins immediately after the channel is sensed to be not busy. So next is the non-persistent method. So first is the one persistent method, then there is the non-persistent method. So in non-persistent method, you are waiting for a particular amount of time and then you're sensing and transmitting. So you're not continuously sensing. So you're not persistent. One persistent means you like किसी के चीज के पीछे लगे रहना. So you are pushing it. You are constantly eager to send your data. So you are continuously sensing it. And whenever you find your channel to be available, you transmit it. But non-persistent is exact opposite. It waits for a particular amount of time, senses, If it finds to be busy, then it waits again, and then it senses again. So whenever it will find that a particular channel is available, it will transmit. So that is non-persistent. So in non-persistent channel, the channel will be the retransmission will happen every waiting time. After every waiting time, the transmission will happen, or retransmission. So it will not happen immediately after the channel becomes available, but after some time. So you have the number of sensing that operation that you have to do is much less. Next is P persistence. So in P persistent, you are persistent about sending the data, but not as much as one persistent. So P is a fraction here. So P is less than 1. So you are maybe 90% as persistent as one persistent method. So here what you will do is you will continuously sense, and whenever you find that your channel is not busy, you will do a lucky draw. You will draw a random number R. If R is less than P, then you will wait for a time slot, and then you will sense. If R is less than P, then you will send, or you will, sorry, if R is less than P, then you will send. But whenever you find the channel to be busy, you will send only if R is less than P, where R is a random integer drawn by you. So this is a random integer. Now, you will wait for a time slot, but if R is greater than P, if R is greater than P, then you have to wait for a time slot, and you will sense again. So now you are basically doing a non-persistent. So if R is less than P, you will be one persistent. If R is greater than P, you will be non-persistent. So after waiting a time slot, you find a channel to be busy. So you wait again, and this time you find the channel to be available. Again you do a lucky draw, and if R is less than P, send, or you do non-persistent method again. So you do one persistent method whenever channel is busy, up until the channel becomes available. Whenever the channel becomes available, you switch to non-persistent method, or you send the data depending on the value of R drawn. So if P is say 0.7, that means it will be one persistent 70% of the time. That is, it will transmit just after the data is channel is available, whereas it will be non-persistent 30% of the time. So P persistent means it will be P percentage 1 persistent and 100 minus P percent non-persistent. So so this is P persistent method. So in one persistent method, the session will send whenever it has to send. In non-persistent method, it will wait randomly, and then if the channel is available, only after then it will transmit. Whereas non-persistent P persistent method is a mixture of these two, and will take one of these two depending on the value of depending on the value of the random integer drawn. So this is the example of persistence method. Now let's come back to CSMA CD. Beg your pardon. Let's come back to CSMA CD. So in CSMA CD, you first initialize the reattempt counter to 0, and then you start your persistence method. So using persistence method, you will wait for some time. So you will wait for some time using the persistence method. Now, once you have waited for some time, then you will go to the decision. The decision is that you will transmit, and if the transmission, the decision is that you will transmit, and if you transmit and then receive properly, that means the message has been transmitted. So it is done. Now, if it is done and the message that comes back is acknowledgement, that is, there is no collision, then you can say that there is so once you have there is no collision detected, that means that if there is no collision detected, that means the message transmission is success. But if there is a collision detected, then you have to send a jamming signal. That is, if there is a collision detected, you will just pause the network, say, hey, there has been a collision, so please don't transmit for now. So you will send a jamming signal, and you will increase the reattempt counter, because you have to do a reattempt of this transmission. But if this reattempt, the number of reattempt that you are attempting is greater than the maximum allowed, then of course you will not be allowed to transmit. So if you will not be allowed to transmit, you have to abort. But if the number of reattempt is within the limit, then you get a second chance. So, but you will not get this second chance immediately. So you will not get this second chance immediately. Instead, you will have to wait for a backoff time, because the others will attempt their first retransmission maybe. So they will have to be given priority. So you have to wait. So how will you wait? Again, backoff is generated using a formula. So you basically generate a random number R, and then TB is R into TFR, where TFR is the frame time. So this is the frame duration. So if TFR is the frame duration, then R into TFR gives you the backoff time. So this is the time that the system will wait before it can again apply one of the persistent method and then send the message. So there, whenever you have to reattempt, you are getting penalized by the backoff time plus the persistence time. So this contributes to latency. Thus, the more number of reattempts you have to do, the more latency increases on your end. but you cannot have latency beyond certain limit. So that's why your number of reattempts is limited, so that you don't congest the network, and also the latency is under control. So this is CSMA CD. So in CSMA CD there is an analysis. This analysis is the energy level analysis, they are saying. So in so yes. Huh. So CSMA CA, another analysis for CSMA CA is energy level analysis. In energy level analysis, we say that there are three levels of energy in the channel. The three levels are zero when there is nothing being transmitted, normal when some channel is being transmitted, and abnormal when there is a collision. So in during abnormal channel level, you can say there has been a collision because there are simultaneously two packets in the channel. So there has to be a collision. The throughput of CSMA, so the throughput of CSMA CD is greater than that of pure or slotted Aloha. The maximum throughput occurs at different values of G, where G is the offered traffic load. So G is the offered traffic load. Offered traffic load. So for the one persistent method, the maximum throughput is around 50% when G equal to 1. For the non-persistent method, the maximum throughput can go up to 90% when G is between 3 and 8. So this analysis is out of the scope, so we will not be going there. And traditional Ethernet or wired communication, these are the main application areas of CSMA CD. In wireless, we have to avoid collision. We cannot just detect collision and keep it there. So this is mostly used for wired communication. CSMA CD is mostly used for wired. So what is used for wireless? For wireless, mostly CSMA CA is used. CSMA CA is basically avoiding collisions. So it is clearing the path before transmitting and ensuring that during transmission no one else can transmit their frames. But it cannot manually force every other station to not send data. So instead it uses a clear strategy of using random backups and random waiting times to ensure everyone transmits at very different times so that there is no collision. So in CSMA CA, again, whenever a station has a frame to send, it will initialize the reattempt counter. This is the first thing common to both CSMA CA and CSMA CD. Initialize the reattempt counter, because we are only allowed a certain number of reattempts. Then once we have initialized that, we will go to the carrier sensing. So if the carrier is sensed to be free, so if there the carrier is not free, then of course you will wait. But whenever it is free, whenever carrier channel free is true, you will wait for IFS. IFS is interframe space. So even if the channel is free, before starting CSMA CA process, you have to wait for IFS amount of time, even if channel is free. So that is one backoff. There are such multiple backoffs and waiting times inbuilt in CSMA CA to ensure that everyone transmits at very different times. Next, again, there is a contention window. In this contention window, there are multiple users who want to transmit. So you are contending for a single slot, for a particular slot with multiple users. So which slot will you get? This is solved again by drawing a random integer. So you choose a random integer. So you choose a random integer r equal to rand. So you choose a random integer such that it is between 0 to 2k minus 1. Just this is the 2 to the power k minus 1. So between 0 and 2 to the power k minus 1. And then you will use the particular rth slot. So if you draw 1, you will use the first slot. If you draw 2, you will use the second slot, like that. And once you have been given a slot, you will utilize that to send RTS. RTS is a request to send. So once you have been allotted your slot, then you will send a request that I want to send something. So in a way, you are trying to gauge whether sending the packet will lead to collision or not. Once you send the RTS, you start a timer, and in that timer you basically wait for CTS. CTS is the clear to send. CTS is clear to send. This is the complementary of RTS. So if sender complementary of RTS, if sender to receiver is CTS, RTS, sorry, sender to receiver is RTS, then receiver to sender is CTS. Receiver to sender is CTS, which means the receiver acknowledges that the path is clear to send. Once the CTS has been received before the timer runs out, CTS has been received before the timer runs out, you will again wait for IFS. So even though you have got an acknowledgement from the receiver that it is ready to receive and the channel is ready to send, you will still wait for an IFS amount of time, and then you will send the frame, and then you will start a second timer. So this timer and this timer are not related. This is T1, this is T2. So in the second timer, you will wait for the acknowledgement. So you have sent the message, now you will wait for the acknowledgement. So before the timer runs out, if you get back the acknowledgement, that means your message transmission has been successfully done without any collisions. Receiving back the ACK is a guarantee that there has been no collision in the intervening path. So if that is true, your mission is successful and you can leave and you can wait for the next message. But if not, if ACK is not received before time, that is considered as a failure. That is, the channel has been busy or there has been a collision. So there are two ways. So there are two timers. If any one of the timer runs out, if the CTS timer runs out or the ACK timer runs out, you end up in a failure. So if you don't get a clear to send, or you get a clear to send but you don't get an acknowledgement, you are a failure. So you will increase the reattempt counter and reattempt again. So, but again we have another decision to make, because the number of reattempts is limited. So if the number of reattempt is less than the number of reattempts allowed, then only we can proceed, or else we have to abort our message. And once we see that the number of reattempts is not greater than the limit, we will wait for a backoff time. So immediately after failing to send a message, you don't get to send it again. You have to, in the interim, wait for a backoff time. And this backoff time is derived again by drawing a random integer tb and multiplying it with the frame time. And this r is varying from 0 to 2 to the power k minus 1, where k is the number of computers. Sorry, k is the number of reattempts. So k is the number of reattempts. Now you can see this backoff time itself is not dynamic. It's not static, it is dynamic. That means with every passing reattempt, TB increases. TB increases with each reattempt. So the maximum amount of time that you have to wait before retransmitting again will increase. TB increases with increasing reattempts. That means the more number of reattempts you do, the more deprioritized you become. So you have to wait longer time to get served. So the more reattempts you do, the more deprioritized you become in the network, and the more number of attempts you have to do before you can send the message successfully. So this is the concept behind choosing a random number between 0 and 2 to the power k minus 1. And once you have waited out that time, then you can start the process again, provided k is within the limit. So in this way, since the communication is only happening when there are clear request acknowledgement, message acknowledgement, 4 times the messages are getting exchanged between sender and receiver, this ensures that there has been no collision throughout. So there are multiple components of avoiding collision in CSMA CA. So multiple players come together to make collision avoidance possible. First of those players is interframe space. First, collisions are avoided by deferring transmission even if channel is found idle. So the first way you avoid collision is not allowing messages to be transmitted just when the channel gets slow, idle. So even if the channel gets idle, you have to wait some time before you can transmit. So you have to be patient. That is first part. So this is interference times. Interference IFS time allows the front of the transmitted signal by the distant station to reach the station. So why is this IFS time needed? Because you have to be sure that no other message station has started transmitting frames. So if you are sure, then only you should start your process. Thus, IFS time so IFS time IFS time is for that, and this IFS time for various stations might be different. And if you want to give a priority to a certain station, you can change the IFS. So a station that is assigned a shorter IFS has a higher priority. So this is a kind of priority pass. Next, there is the contention window. Contention window is basically the transmission time that is equally divided among all the competing stations. So for a particular time, there may be a time window of transmission available, and that time window of transmission is divided equally among all the senders, and then the senders get to decide this by drawing random numbers. The senders get to decide when they can send their data. So that is a and the contention window. And the third part is acknowledgement. So acknowledgement is another component of making sure collision doesn't happen. So this is more of a collision detection thing than a collision avoidance thing. So despite your best measures, if you still encounter a collision, which you might, then acknowledgement makes you aware that there has been a collision, because acknowledgement has not come yet. So by non-receipt of acknowledgement, you can conclude that there has been a collision. I am joining back after 2 minutes. So next we will be So CSMA CA has been discussed. Now CSMA CA is mostly used for wireless networks, and is this is not a very sophisticated network, but still it does the job. So other methods that are more applicable in a controlled environment, so in a small like environment where multiple stations are connected in a LAN environment, there you can have controlled access. Controlled access means that the stations are centrally controlled. Stations are centrally controlled. And second is their transmission happens by algorithm. So this is not at all the chaotic like CSMA or Aloha. Here the stations do not have free will. The stations do not have free will of transmitting whenever they want. The transmission happens by a fixed algorithm. So this algorithm differs, and hence there are different protocols. The first protocol is reservation. In reservation, it is like when we book tickets in IRCTC. Say 1,000 people wants to go from Kolkata to Delhi at a particular date, say 15th April. 15th April in the morning, there is one train from Kolkata to Delhi, and 1,000 people want to go on that train. 1,000 people want to go at that time from Kolkata to Delhi. But there are only 500 seats in that particular express train. So what happens? We log on to IRCTC and then we try to get the seats. We try to reserve our seats, and only the first 500 people who can reserve first in a first come first serve basis will get the seats. So reservation works like that. If 100 stations want to send data at a particular time, then they have to make bookings, and there may be 50 open slots available. So only 50 stations can transmit. Or if there are 100 slots available, then all the 100 stations can transmit. But they will be allotted the slot to transmit via reservation, and they can only transmit in their own station slots. Only transmit in their own slots. Only transmit in their reserved slots. So here, say there are n stations. So there are n reservation mini slots in the reservation frame. Each mini slot belongs to a station. When a station needs to send the data, it will make a reservation on a particular mini slot on a say first come first serve basis, or there might be another algorithm, but the easiest one is first come first serve basis. So the stations will make their reservation on a first come first serve basis for mini slots, and then they will send their message in that mini slot only. If in that particular mini slot station cannot transmit its data completely, then it has to make another booking so that it can transmit. But it cannot infringe on another station's mini slot. So there is a centrally allocated timing, and centrally allocated timing for transmission, and every station has to obey that central allocation. So here station 1 makes a reservation in mini slot 1. Then station 4, 3 and have to send something. So they also make their reservation in 4 and 3. So the stations will make reservation in the reservation method. So station 3 and 4 makes reservations. So whenever they have to make the reservation, they will turn their own slot into 1. So all slots are 0 by default, and whenever they will turn their own mini slot into 1, then that particular slot is reserved. A particular time slot is reserved for that station. Next we come to polling. So polling is a good name. Another good name for this method is survey. So this is a survey method. So here this is a very polite method. Every station asks whether others have to transmit or not. If others do not have to transmit, then it will transmit. So it will go around and politely ask everyone whether you have to transmit or not. If everyone says we do not have to transmit, only then it will transmit. But if there are 10 stations and everyone asking everyone, will create unnecessary chaos. So to avoid that precisely, what happens is there is a particular primary station. So one device is asked to be the surveyor. So this primary station is the surveyor. Instead of everyone becoming surveyor, this primary station is the surveyor or polling agent. Now this primary station has to act as an arbiter for all other stations. So whenever a particular secondary station has some data to send, it will tell the primary station. So in polling, the secondary station will, if it has anything to send, it will tell the primary station that I have something to send. So when that is done, or what might happen is that the primary device might go around and ask everyone whether you have to send something or not, So when that is happening and someone, all data exchange must be made to primary device even when the ultimate destination is the secondary device. The primary device controls the link, the secondary devices follow its instruction. It is up to the primary device to determine which device is allowed to use the channel at a given time. The primary device is therefore the initiator of the session. So whenever a secondary function has been, whenever there are secondary function has something to send, the primary will go around surveying whether anyone has to send something or not. So the first thing that they have to do is, the first thing they will do is, it will go around and ask whether someone has something to send or not. If station A says I have something to send, if station A says I do not have anything to send, it will just send a negative acknowledgement or a NAC frame. So here primary asks station A, do you have something to send? Primary station A says no. So it sends a NAC frame. So primary understands the NAC frame and then moves on to pole B. B, instead of sending a NAC frame, sends a data with the receiver's address on it. And the primary will then send the data to the destination, and once that is done, it will send an acknowledgement to B telling that the transmission has been completed. So it will go around asking stations which one has to send. If someone has to send, it will take the data, send it to the destination and send an acknowledgement. Now if primary has to send something, then it will not use the poll function, it will use the select function. In the select function, it will just select the destination computer where it has to send its data and send the data. So it will select B. B will say, okay, I am ready to receive. It will send the data and B will send the acknowledgement for receiving the data. So select function is used when primary is sender. So select function is used when primary is sender. Primary is sender. Whereas poll is used if secondary is sender. So the poll function is used by the primary to solicit transmissions from the secondary devices. So whenever the primary is ready to receive the data, it must poll each device in turn if it has anything to say. When the first secondary is approached, it responds either with a NAC frame if it does not have anything to say, or it will send the data. If the response is negative, that is a NAC frame, then the primary will simply move on to the next device. Now, last method is token passing. In token passing method, there is a logical ring of devices. So the devices are all organized in a ring. The devices are organized in a ring, and a token is passed around. So there is a particular token. This token is passed around, and whoever has the token has the right to send. So if there are 4 stations, say A, B, C and D, then B might send some data, and if B sends some data, then C will, if B has the token, it might send some data. And if B does not have any data to send, or it is done sending its data, then it will pass the token to C. And when C has the token, C will send whatever data it has to send. If not, it will pass to D. Or if it is done for sending the data, it will pass to D. So the token will be passed around. The token will be passed around, and you have to wait for your turn to get the token, and only then you can transmit the data. So there is no chance of collision because only one person has the token and only they can transmit. So there can never be 2 people transmitting in the same network. So this is token passing network. So everyone sends the data and they are processed. Everyone sends the data when they have the token, and then they pass the token when they are done. So it is a very simple process. Once that is done, next we will go on to, so that is done CSMA. So we have done random access, we have done controlled access. So CSMA CD, CSMA CA, and now we have reservation, token passing and polling. So once that is done, we will go on to problem solving session. So next part of our lecture will be devoted to solving problems for week 10. So first question is, a CSMA CD bus spans a distance of 2 km. Here bus means a long wire which carries data. So a CSMA CD bus spans a distance of 2 km. Detection time is negligible. The propagation speed in LAN cable is 2.5 into 10 to the power 8 meters per second. If the data rate is 10 MB megabits per second, what is the minimum frame size? So basically we have to find that if data rate is 10 Mbps, then the frame size will be just whatever number of bits can be transmitted throughout the length of the cable. in the duration of propagation. So the propagation time, what is the propagation time? Let's find the end-to-end propagation time. So the first thing we need to find is end-to-end propagation time, and whatever that time is, how many bits you can send in that time determines the frame size. So end-to-end, because if you send less than that time, if you send a frame smaller than that, then you are basically misusing resources, because the whole channel is blocked. You might as well use the whole channel. So end-to-end propagation time is 2 kilometers, so 2000 meters, 2 into 10 to the power 3 by 2.5 into 10 to the power 8. So this is 0.8 into 10 to the power minus 5. So 8 into 10 to the power minus 6. 8 microseconds. So let's keep it 8 into 10 to the power minus 6 seconds. So what is the minimum frame size? Minimum frame size is just whatever number of bits you can send in this amount of time. So 10 million bits are being sent per second. So 10 to the power 6 bits per second, and you have 8 microseconds to send. So 8 into 10 to the power minus 6 seconds, and you have 10 into 10 to the power 6 bits. So you ultimately have 80 bits as frame. So none of the above. The correct answer is none of the above. This will be 80 bits, not 100 bits. This is wrong. So it will be 80 bits. The correct answer is D. How does CSMA CDI react to collision? So if CSMA CDI detects a collision, what will it do? It will send a jamming signal and increase the reattempt counter. So reattempt counter. Hosts involved in the collision send a jam signal and then run an algorithm before retransmitting. So it will send a jamming signal, and then this algorithm, what is this algorithm called? This algorithm is called back off. It will do back off and then it will retransmit. So option C. C for China. So host RTS is a CSMA CA thing. So this is not applicable for CSMA CA. And if all systems jam the network and all begin transmitting again, so you will again face the same problem. So if all of them stop at the same time and all of them start at the same time, you will again face the same problem that you faced previously. So the hosts involved in the collision will send a jam signal and then run an algorithm that is called back off before it will retransmit. So correct answer is C. Next, what is the name of the algorithm used in CSMA CD network in order to avoid repeated collisions? So to avoid repeated collision, the algorithm that you do is when you fail to transmit a particular message, you So what is the name of the algorithm? So whenever there is a collision, the CSMA in CSMA CD network, collision avoidance is now of course CSMA CA, so it is not applicable here. So you will wait for some time. This wait is called exponential back off. So this is exponential back off. And what is exponential back off? You choose R between 0 and 2 to the power k minus 1, where k is the current number of reattempt. K is current number of reattempt. So with the increasing number of reattempts, the random number average, the average of this random number will also exponentially increase. So the average back off time increases exponentially. That is why it is called an exponential back off algorithm. Next, which is not the CSMA protocol? Non-persistent CSMA, P-persistent CSMA, X-persistent CSMA, none of them. So non-persistent, P-persistent. So in CSMA you have the choice. In CSMA protocols you have the choice to use a particular persistence method. And how many are there? There is one persistent. That is not, there is non-persistent. And then there is P-persistent. So these are the three type of persistence methods, and hence these are the three types of CSMA based on the persistence method used. So X persistent CSMA is not a standard name, so we'll just rule out X persistent CSMA. So the correct answer is C. Next, which of the following is advantageous feature of wireless communication compared to wired communication? So what is the advantage here of wireless communication over wired communication? So is it time division multiplexing, frequency multiplexing, spatial multiplexing, or all of the above? So time division multiplexing is something that you can do both in wired and wireless, because there is a concept of time in both. Also, frequency division multiplexing is something you can do both in wired and wireless, because both of them involve the use of the concept of frequency, which is present in both. Which is present in both wired and wireless. So TDM is present in both wired and wireless. FDM is also present in both wired and wireless. But there is no free space in wired communication. So in wired communication, there is no free space for the beams to move. The beams follow a particular constrained path along the wire. So there is no scope of following a different path. So there is no free space to move around. And what is spatial multiplexing? Spatial multiplexing is when you have multiple beams and you separate them in space. That is, you send them in different directions, so they do not interfere with each other. So C1, C2, C3 here are spatially multiplexed. So see, they are not interfering with each other and communication is happening. But in wired communication, everyone has to go through the same single wire, so they cannot be separated in space per se. So this is only found in wireless. So this is only found in wireless. So correct answer is C, spatial multiplexing. Now, carrier sense multiplexing, the possibility in carrier sense multiple access, the possibility of collision still exists because of sensing delay, propagation delay, transmission delay. So here in carrier sense multiple access, The random part, which makes sure that you may not have a, which does not let you make sure that there will be no collision, that random part is propagation delay. So even if you know that all stations are not likely to send right now, even if you know that these stations are not likely to send the message right now, you will can still encounter a collision only because the message that was supposed to come hasn't arrived yet, or the message that was not supposed to start has started. So because of the unpredictable nature of propagation delay, you can still suffer from collisions. So the main culprit in the collision in the in collision for carrier sense multiple access is propagation delay. Next, the carrier sensing mechanism used in wireless network is, okay, so this is network allocation vector. So this is something I have to teach. So this is something I have skipped. So how does the station know what the channel is having currently? So how does the station estimate the channel load? So how does the station estimate the channel load? So in that case, it uses something called network allocation vector. When station, so in how does a network allocation vector work? So when a station sends an RDS frame, it includes the duration of time that it needs to occupy the channel. So when you are sending a request to send, you of course give an estimate of how much time you will need to send it. Just give me 1 minute. So yeah, when a station sends an RTS frame, it includes the duration of time that it needs to occupy the channel. The stations that are affected by this transmission create a timer called network allocation vector. So the stations that uh, um, the stations that have to transmit but cannot because this particular station is asking to transmit, they will instead create something called a network allocation vector that shows how much time must pass before these stations are allowed to check the channel for idleness. Each time a station accesses the system and sends an RTS frame, other stations start the NAV. So whenever one station gives RTS, means others start their NAV. One station gives RTS implies other stations start NAV. Start NAV. So each station before sensing physical medium, in other words, each station before sensing the physical medium to see if it is idle, first checks its NAV to see it has expired. So instead of sensing every millisecond, it will wait for a particular amount of time for the NAV and then it will sense again. So carrier sensing mechanism is NAV or network allocation vector. Next, what is the hidden node problem in CSMA? Is it inability to hear another station's broadcast due to distance, or inability to hear another station's broadcast due to difference in transmit power, or is it both A and B? So hidden node problem means when you think a particular station does not have anything to send, but it actually has something to send, or is particularly sending something, but you cannot sense it. So you cannot sense other nodes transmission. Hidden node means inability to sense another node's transmission. So another node has transmitted something, but you cannot hear it. So that is, you cannot sense that that particular node is transmitting. You cannot sense it. So inability to sense another node's transmission. So what is the root cause of that? It can be distance, because the node is so far away that the signal from that node is taking a long time to come. So you are not being able to form a decision whether that node is sending or not. And okay, next question is, what is interframe space? So interframe space is the time between completion of the transmission of the last frame and starting transmission of the next frame. Time period between completion of the transmission of last frame and starting transmission of next frame. So first one is time period between completion of transmission of last frame and starting transmission of next frame. Another is completion of last frame, starting of next frame apart from the back off. And another is time period between completion of transmission of last frame and starting carrier sensing. So interframe space is basically you find the time between two frame transmissions, but you have to exclude the back off, because back off is something that you are deliberately doing. So interframe space is not that. So it is the waiting time is composed of two parts. In CSMA CA, waiting time is made of two parts. One is IFS, another is back off. So there is IFS and there is back off. So waiting time is the sum of these two. So W is equal to IFS plus R into TFR. So R into TFR is the TB, exponential back off. So where R belongs to 0 to 2 to the power k minus 1. So the correct answer is option B. Next is, which of the following has been introduced to solve the hidden node problem? So RTS and CTS. RTS CTS is exclusively this. RTS STS is a bonded pair, so RTS CTS pair. So RTS cannot exist without CTS and vice versa. So RTS CTS is a bonded pair, and they are introduced to solve the hidden node problem. That is, even before transmitting, you are waiting for the RTS to go to every station. This goes to every station. To check transmission. This ensures 100% that there will be no collision. So RTCT is both. So this brings us to the conclusion of today's problem solving session in CSMA CA. These problems along with their solutions will be duly uploaded in the NPTEL website in the problem solving session tab. And with that, I would like to finish today's lecture. Thank you. You may stop your video here. well.